Hey there, thanks for tuning in. I'm Sam Moser, and this is a detailed walkthrough of a full van conversion on this Ram Promaster 136-inch high-roof van. Let's jump right in. I started by removing the floor that came in the van. I unbolted the cargo tie-down points and then began to pry it up and break loose the adhesive that it's glued down with. The plan is to insulate under the floor and then reinstall this original floor, so the goal is to get it out with as little damage to the floor as possible. The floor is all a single continuous piece of plywood with a nice laminate on top, so it makes a good option for the finished floor surface. I'll be using 1-inch XPS foam insulation along with furring strips I planed down to the same thickness of the insulation for extra support under the floor. I cut and laid out my furring strips and then drilled some pocket holes to fasten them together where needed. I used glue in addition to the pocket hole screws to fasten each joint together and repeated across the whole floor. Once the floor substructure was assembled, I pulled it out so I could clean up the floor a bit. With the floor surface prepped, I brought the substructure back in and prepared to glue it down. I used a high-strength marine adhesive for this. I'll add links in the video description for materials used for the build. I weighed the floor down with a variety of heavy stuff while the glue cured. The next day, I cut pieces of insulation to fit between each section. I used a foam construction adhesive to glue the insulation in place and seal up any gaps between the wood strips and the foam board, as well as along the edges. The foam adhesive is easy to trim flush once it dries. Next, I brought the main floor piece back in the van. I had to route recesses in the foam where the cargo tie-down points are as they extend past the bottom of the floor. I did this with a router and a simple circular template. Now I was ready to spread adhesive for gluing the floor down. Again, I'm using a high-strength marine adhesive. In addition to the adhesive, I used the cargo tie-down points with longer bolts to bolt the floor down. That was it for the floor install. Onto the wall framing. For the wall framing, I'll be creating a wood interior structure that bolts into the metal structure of the van. I'm attaching the framing to the van using 1/4-20 threaded rivets. Once the holes are marked and drilled out, I remove burrs with a reaming tool and then apply a metal primer to the exposed bare steel. Then I install the threaded rivet with a pneumatic rivet gun. There are a few different types of tools for this, but this one is the quickest. I like to set the rivets while the primer is still wet, and then it all dries and sets up together to prevent rust around the rivet. Here is my upper horizontal framing member. It has a bevel on the back to fit the angle of the wall, and a more minor bevel on the front where the wall panel will attach. I also had to drill slight counterbores on the back so the board could sit flat on the wall, even though the head of the threaded rivet sits a little proud of the surface. The thickness was determined by the depth I needed to fur the wall out in order for a continuous run of strut channel to be mounted on top of it and clear the protruding metal column in the center of the van. First, I was just test fitting all of them to make sure all my bolt holes line up, and then I went back and applied a foam construction adhesive for the final assembly in addition to the bolts. After this, I followed the same process to add a support along the lower horizontal section. Next, I added furring strips to the ceiling. These are attached with glue and screws as they will only hold a thin ceiling panel. The upper cabinets will be anchored to strut channel that is bolted in place rather than to wood furring strips. Next, I framed out a divider wall that will separate the main area from the rear wet bath. I made this by laminating 2 strips of 3/4-inch plywood together to create a thicker wall cavity for running plumbing through. Before doing the rest of the wall framing, I added sound deadening to the walls and wheel wells. Returning to the wall framing, I went through and filled in each section with vertical supports. For all this internal framing, I'm using strips I cut from plywood, specifically AC radiata pine plywood. Radiata pine plywood tends to be less warped and have fewer knots and inconsistencies than many of the other construction-grade plywoods, while being lighter than some of the denser plywoods like Baltic birch, which we'll save for uses like the cabinets where we want a high-quality ply. The vertical framing strips are glued and pocket hole screwed to the horizontal framing members. The upper stretches are angled at the top and bottom to fit the slant in the wall. For the ceiling furring strips at the front, I glued a block to the roof at the front to hold the furring strips, as there isn't anything else here that the front end can fasten to. At the back, I glued and screwed some blocking in place that I could then fasten the furring strips to for support at the rear end. If you're enjoying this video, you can help me out by hitting the like button. Thank you. At this point, I felt that I had enough of the framing in place to start running all the wiring. In a mobile application like a camper, all of your wiring should be stranded core. You don't want to use solid core wire such as Romex that you would use in a house. Here I'm using Anchor marine wire. In addition to this, I run the wiring through plastic split loom where needed to protect it from rubbing on metal edges within the van walls. Over time, metal edges can chafe through the wire sheathing if they aren't secured in place and protected. I took advantage of the large open pillar in the middle of the driver's side wall for routing many of the wires from the floor area where the electrical system will be to the upper portions of the wall. Once wires were roughly in place, I went along and used mounting zip ties to fasten the wires to the framing. Beyond the split loom, having wiring that is fastened in place will also prevent the wires getting damaged over time. Here's what these mounting zip ties look like. I'll add a few more wires and tidy everything up a bit more as I go through the rest of the build, but now the majority of the wiring is roughed in. Next up, I worked on the roof vents. One max air towards the front and a smaller round exhaust fan above the shower. This will just be a quick overview of the process and not a detailed install guide for these. I started by cutting out the holes using a jigsaw with a fine-toothed metal cutting blade. Then, I removed burrs and cleaned up the edges using files and sandpaper. Next, I pre-drilled holes for all the screws. Then, I glued in shim blocks to create a flat surface for the fan flange using a fast cure marine adhesive. Now I applied primer to the exposed metal edges for rust prevention. For the back fan, I added butyl tape under the flange and also used it to build up the low spots between the roof ribs. Then I screwed the fan into place and trimmed away the excess butyl tape. Same thing for the max air fan flange. I added butyl tape under the flange and then screwed it down. Since this one has a plastic flange, you have to be careful to not over-tighten the screws and bend or crack the plastic, so I use a screwdriver to do the final tightening by hand. The last step is to paint on Flex Seal as a final waterproofing layer over the base and screws. I use masking tape for this to get clean and tidy edges. Paint on a thick layer and then pull the tape while the Flex Seal is still wet. Now the upper portion of each fan can be screwed in place, and that's it. After this, be sure to clean the van well to get off any stray metal shavings. Once all the sealants have dried, come back and do a water test to check for leaks. Easier to fix now than later. With framing and wiring in place, it was time for insulation. I'm using Havelock wool insulation, which comes in bats that are 16 inches wide, 48 inches long, and 2 inches thick. The insulation is easy to cut with scissors or tear to fit. I use 3M Super 77 spray adhesive to hold the insulation in place where needed, because in many places the framing is enough to hold it in place on its own. With the insulation, I fill not just the large wall areas, but also fill the smaller nooks and crannies within the metal structure of the van. Here, I'm just installing a first pass of insulation everywhere, but since some of the wall sections are thicker than 2 inches, I'll come back later and install a second layer to fill the whole wall cavity before closing up the walls with panels. Next, I installed aluminum strut channel along the walls and ceiling. I marked out the mounting hole locations, then drilled holes for the bolts using a simple jig to get the drill bit centered on the channel. On my framing here, there are a few bolts that are just to hold the framing in place, and then there is a series of evenly spaced holes that the bolts for the channel will pass all the way through and go into the threaded rivets in the metal frame of the van that I had installed before the wood framing. The channel bolts on using 1/4-20 stainless steel bolts and lock washers. The stretches on the ceiling bolt directly into the roof ribs, but I did add a dense rubber backing at each bolt point to create a thermal break, as well as to be able to make up for the rib height difference since there's one that isn't level with the others. This strut channel is what the cabinets and interior items will mount to. I did this to test out a different approach to cabinet mounting versus just screwing them into the wood framing. Overall, I liked the addition of the strut channel, and I felt it made for a very sturdy and robust way to mount the cabinets that also made it easier to remove and reinstall cabinets if needed later. After this, I added a little more vertical framing to the upper part of the walls and then began fitting the wall paneling. I used 1/4-inch plywood for all the wall paneling, except for the outer ceiling panels, where I used 1/8 inch as they needed to curve quite a bit. I tried to locate seams between wall panel sections in places where they'd be hidden by cabinet edges or other transitions. The wall paneling is fairly straightforward. It just takes a lot of test fitting, scribing, and fine-tuning to get each piece of the puzzle together. Where needed, I made a cardboard template before cutting my plywood sheets. I boxed in the passenger wheel well area to make a platform for mounting the water tank. I will also utilize the strut channel on this side for mounting aluminum strapping to hold the water tank tight against the wall. I will be attaching all the wall panels with screws rather than nailing it permanently in place. As I've worked on and done repairs on more vans, I've continued to think about how to make the vans I build easier to repair or upgrade years down the road, something that I think a lot of builders, both professional and DIY, overlook. I think I made some good strides in this direction on this van by carefully planning where the wall panels will meet, using screws not nails, and using a cabinet mounting system that makes it strong but easy to unbolt cabinets. All details that are largely invisible in the final product, but make a big difference. This back corner will get built a little different than the other walls, as this back area will have a wet bath, and these will be waterproofed shower walls. More on this later in the build. Here I'm just adding some framing and then boxing in the wheel well. For water to roll off, I added a slight slope to the top of the well box. The areas around the door pillars and openings are the trickiest to build around, with again lots of scribing, cutting, test fitting, and recutting until it all meshes together just right. To make it more complicated, in a Promaster, you need to make sure anything you build around the rear vertical columns is removable if you ever want to be able to change a brake light later, because in order to open up the tail light, you need to undo a bolt from inside the rear column. I think this is a poor design on the part of Ram, since in both Sprinters and Transits you can remove the taillight without access to this inner area. I added some blocking in the middle with a threaded insert and some threaded rivets by the base, so the rear corner trim can be unbolted and opened up in the future. Now on to the window install. I prefer to install windows earlier on in the build if possible, but in this case I ordered them when I first started on the van, but they had a fairly long lead time until they shipped. Here I'm cutting the opening for the slider door window. I tested out using a metal shear tool, but it wasn't working very well for this, so I went back to my tried and true jigsaw instead. Then I test fit the window and fine-tuned with a flap disc on an angle grinder. This type of window installs with a trim ring, and so I needed to cut out this metal support at the middle of the interior opening without cutting through the outer sheet metal. I did this with a cutting wheel on the grinder and a piece of scrap metal as a backer to make sure I didn't cut too deep. Same thing for the smaller bunk window on the driver's side. Cut out, test fit, and fine-tune till it fits with just a little wiggle room, since metal can expand and contract with temperature in the future. I went ahead and traced an outline onto my wall panel while I had full access from the outside. Once the holes were ready, I cleaned up the edges with some sandpaper, wiped the surfaces clean, and then painted on some metal primer for rust prevention. Hey, that's a bit of a theme for any of the metal cutting or modification on a van build. These builds take time because there's a lot in the small details. Later, once the paint dried, I got the windows ready to install by applying the weather sealing gasket to the exterior window flange. To put the window in, first spray down the surface with glass cleaner. This allows you to adjust the window slightly while securing it in place with the trim ring. I added a small strip of masking tape to hold it in place, then headed to the inside to screw on the trim ring. I used a small ruler to make sure the window was level as I tightened the trim ring which clamps the window in place. The process is the same for the big window. I think trim ring style windows are more foolproof to install than ones that have to be glued in place with window weld. Keep this in mind when window shopping. When tightening all the screws, I like to work in a circle doing multiple passes to make sure I'm applying even pressure the full way around. I also used the torque limiter on the drill to make sure I wasn't over cranking the screws. That was it for installing the windows. Now I could go back and finish the wall framing around the window, as well as build my window box, which I'll integrate into the wall panel. At this point, I was just about ready to close up the walls, so I went through and did a second pass of insulation to fill any deeper areas or spots I didn't get before. Again, I used some spray adhesive to hold it in place. This works well even for the spots where you're layering the insulation over itself. Alright, so let's take a closer look at what I've done up to this point. I created an insulated floor, installed wood framing along with aluminum strut channel on the walls and ceiling, installed roof vents and windows, roughed in and secured all my wiring, and insulated throughout. To recap some details, the framing and aluminum channel is bolted in place with threaded rivets. The framing is joined together with pocket hole screws at the intersections to create a strong assembly. The wiring is secured to the framing using mounting zip ties that are recessed so that the wall and ceiling panels are able to sit flush. Split loom is used for extra protection where needed for the wiring. Okay, let's go on with the rest of the build. I attached all of the now painted wall panels with screws, feeding my wire through where needed for lights, outlets, or other items. If I forgot a wire though, I can still open up a section and fish it out. My next stage was to build out the mechanical systems in the van. The electrical system and heater will be housed under the base of what will be the couch and bed. When I ran my wiring, I routed them such that they all originated from this area, as here's where all the main breakers and fuses will be. I started by figuring out the best way to locate all my components within the space and then began the heater install. I first marked the location for the heater holes and mounting plate, and then cut out the floor in this area. I need to cut through all layers of the floor, so it's important that the location for this is clear underneath the van and not located above a metal frame member or the van itself. Once the hole was cut, I used metal flashing and high temperature sealant to create a flange that seals off all the edges of the floor to prevent any heater fumes under the van from finding their way in. Next, I took the heater with all the connections pre-installed and fed it through my hole and then screwed it in place. The rest of the heater install took place from underneath the van, and this video won't cover those details. Now onto the electrical system. I brought in all the components and then cut dividers, which will help hold the components in place and create more surfaces for mounting components to. As I went along, I also bundled and routed my wires where they needed to go within the space. The system will have a 12-volt 618 amp-hour battery bank, a 3,000-watt inverter charger, dual 30-amp alternator chargers, a solar charge controller connected to 600 watts of solar on the roof, and all the various cutoffs, breakers, and fuses needed. I like to start by completing all the largest wiring first, as this is the hardest to work with. After that, I go through and connect up the rest of the components, carefully cutting, stripping, and crimping on connectors for each stretch of wiring. Just like in the walls, all the wiring should be securely attached and clamped in place. This will not only prevent the wiring from rubbing on things and getting damaged, but will also prevent connections from working loose compared to if wiring is unsecured and bouncing around when driving. Since this video is an overview of the full build, I won't go into depth onto how to build an electrical system like this, but if you are interested, I have detailed wiring schematics available on my website for electrical systems like this. Those show where fuses are needed and what wire sizes to use throughout for a safe system. Next up, I worked through some of the water system and plumbing. Inside, there's a 30-gallon freshwater tank, and under the van, there's a 20-gallon gray water tank. The pump and accumulator are located under the water tank platform. For all the freshwater distribution, I'm using 1/2-inch PEX piping with PEX clamp rings to secure the fittings. PEX is a good choice in campers, durable, and pretty straightforward to work with. Next to the water heater, I'm building a water heater bypass with 2 3-way valves to make it simple to bypass the heater when sanitizing the water system. Although this location ended up not working for the water heater, and I relocated it later. All of the fittings for the tank are on the back side. These include a fill port and breather tube at the top, and a drain and water pump connection at the bottom. For securing the tank, I shaped aluminum flat bar to create these straps that bolted into the wooden platform at the bottom, and into the cargo track on the top. These will lock the tank in place from side to side and vertical movement. Additionally, I'll add some blocking to the front and back to prevent the tank from being able to slide forward or back. I'll also add a support from the tank platform to the divider wall going on this side to help carry the weight of the cantilevered part of the tank platform. Continuing on, I started working on the interior structure and cabinets. This is where the build really starts to take shape. I built a couch-to-bed platform that utilizes slats and heavy-duty drawer slides so that the platform can easily expand into a full-size bed. It's also on a hinge so you can lift it up to access the electrical system underneath. Behind it, I built an angled backrest with shallow storage cubbies to utilize the space within. From here, I worked my way around, building and fitting all the various cabinets and panels and fitting them to the items they will house. All the cabinets and cabinet doors are made from 1/2-inch Baltic birch plywood. Baltic birch is a stable, high-quality plywood, and using 1/2-inch saves weight over 3/4 inch. The outside of the cabinets and doors will be covered with a Formica laminate, and the insides will be protected with a clear finish. The passenger side will be the galley area, with a sink, cooktop, refrigeration, and microwave in the upper cabinet. The driver's side will house a floor-to-ceiling cabinet to the side of the couch and a large upper cabinet above the couch. The evaporator to the undermount air conditioner will be housed in the upper cabinet here. The rear of the van will have a large floor-to-ceiling storage cabinet opposite the wet bath. Next, I focused on the wet bath. I installed a vent for the composting toilet and then added some additional wall framing for the wall panels. For the floor, I had to build a custom shower pan due to the wheel well and rear column creating an irregular floor shape. To make the shower pan, I constructed a wooden box of the custom shape, used a shower pan insert to create a sloping floor leading to the drain, and then I fiberglassed the whole thing with fiberglass cloth and epoxy, similar to how you would fiberglass a surfboard. This turned out to be a pretty time-consuming way to build a shower pan with all the sanding and smoothing needed between coats of epoxy. But in the end, it worked well for creating the custom shape I needed. I also built a flange into the shower pan such that the shower waterproofing would go over the flange and prevent water from being able to work its way back. Before closing up these walls, I filled the exterior wall with insulation. I glued the pan in place and then added my waterproof wall panels. Here I'm using Schluter Curdy board, which is a lightweight foam waterproofing panel. All the screws and seams in the Curdy need to be covered with Curdy band and the corners with corner patches. Traditionally, this would be applied with thinset, but here I adopted a hybrid approach and am using Aqua Defense instead. I chose this approach because vans move and flex as they drive. Thinset is rigid and can crack, whereas the Aqua Defense remains flexible. I applied a generous coat of it both under and over the Curdy band to get it all adhered together and waterproofed. I used silicone to seal around the vent for the composting toilet. Once this was all set up, I drew out layout lines for my vinyl shower wall tiles. Here, I'm using a vinyl wall tile meant specifically for bathrooms and wet areas from a company called Palisades. This is again a place where I prioritized weight and flexibility of the materials for making the right choice for a mobile environment. I see some builders use real tile in camper vans, but in most cases I don't think it's worth the extra weight and possibility of cracking in the future. Per the manufacturer's instructions for the vinyl tile, I installed this with one of their recommended adhesives and used additional silicone to seal all the seams. From here, I continued finishing out the cabinets, reinstalling them once I had applied the laminate. The trim panel above the slider door will be a control panel for all the systems in the van. For the panel behind the bed, I removed the panel to install some wood strips on it and then reinstalled the panel. I installed under cabinet lighting before putting the upper cabinets back in. For the upper cabinets, I cut and pre-installed the door hinges when they were outside of the van since I had better access to them. For the lower cabinets, I fitted the doors and hinges first and then fitted the fixed panels. At this point, I finished the install of the interior portion of the undermount air conditioner. The only piece inside is the evaporator and blower. The rest of the air conditioner components are located underneath the van. From under the van, 2 refrigerant lines, 1 drain line, and 1 electrical harness run up through the back of the tall cabinet and connect to the evaporator. This style air conditioner works really good if you want to have a high-powered DC air conditioner but don't want to use up any roof space for it. At this point, it all comes together with various finishing panels, trim, and the final install of interior appliances. For this last bit, I'll just let the remainder of the time-lapse roll, and then we can check out the finished van. Thanks for watching along this far.